Okay, welcome back students. Today we shall discuss about PPT 5, which is session 5 of radio communication. So in PPT 5, session 5 in radio communications, we are going to study the concept of noise, signal to noise ratio. What is noise actually? We know in the communication system, our message signal, that is the wanted signal, has to be transmitted from one place to the other place without disturbances. So at the receiver, the voice should receive the replica of the original sound. That is what we speak at the transmitter. It should be received by the receiver and it should produce same sound that we have sent in the transmitter. If not, we can say that some noise is present in the signal. Actually, the wanted signal is our message signal, maybe speech, human voice, any message signal, any informations. That information should be transmitted all over the surface of the earth, and you can receive the information at any point on the earth surface. At the receiver, the same voice or same signal should be reproduced back. Sometimes what happens, suppose if this is a pure message signal, that is our wanted signal, while transmitting this into the space, it has to travel along this space and it will be received by the receiver. Then this signal, while traveling in this space, wind noise or certain climate sounds, some factory sounds, these are all produces some amplitude variations. These amplitude variations may be mixed with this wanted signal, giving rise to the presence of unwanted signal. This presence of unwanted signal along with this wanted signal is called noise. This noise affects the effective transmission, and hence the original sound may not be reproduced exactly. So this noise may be the amplitude variations occur in the space or in the channel between the transmitting station and the receiving station. And also when the signal is received by the receiver, it is processed through many electronic circuits to reproduce the sound, original sound back. While processing through many circuits, the circuit may introduce certain amplitude variations. These amplitude variations may be mixed with the wanted amplitudes, resulting into noise. Therefore, for better transmission, noise has to be reduced. Of course, the noise cannot be removed completely, but however, we can reduce the noise by using some electronic circuits. So in the session 5, we are going to study what is the meaning of noise in the radio communication system. What are the types of noise and qualitative analysis of communication channel. What is communication channel? The message signal can be transmitted either by sky wave or by ground waves. This transmission through the space or through the ground is called channel transmission. This channel may introduce some noise along with the original sound. Now we have to reduce this noise for better transmission and reception. Now, what is noise? See, noise is an unwanted signal that will interfere or merge with the original message signal. When it mix up with the original message signal, the signal will corrupt the parameters of the message signal. Parameters of the message signal is our voice signal is changed due to presence of noise. Therefore, generally we can define noise is unwanted signal present in the original message signal. This disturbs our original message signal. Therefore, the noises are measured usually to reduce it, and it cannot be completely removed. And the noise cannot be completely removed. However, for better transmission, noise can be reduced to as much as small by some electronic circuits. So most common examples of noises are, what types of noises are there, how they are produced. So the most common examples of noise, what happens when noise is present in the communication system, that is examples of noise. Hiss sound in radio receivers. In the old days, when you tune the transistor or radio to some station, along with the original speech or sound or music, you may be hear some hiss sound like that. So the presence of noise may produce that hiss sound in the radio receiver. And also in the telephone conversations, when you converse conversation with some people through telephone, sometimes you may hear the noise. The voice may not be clearly heard. There is some budge noise along with the original sound, that referred as budge sound. So in the television communication, while you are viewing the TV, sometimes the images are flickering. The image is not constant. So you may get flickering of images. That is called flickering in television receivers. That is also referred to as noise. Of course, there are two types of noise errors produced in the telecommunication system: the external noise source and internal noise source. So in the telecommunication system or in any communication system, the unwanted signal is called noise. This unwanted signal will interfere or will merge with the wanted signal either by internal noise source or external noise source. What are the internal noise source? How they are produced? What are the external noise source? How they are produced? See, the external noise source. In this external noise source, the noises are produced due to the external source. The external noise may occur in the channel of communication. That is, there is a channel for communication between the transmitter and the receiver. So between the transmitter and the receiver, when the signal is transmitted through the channel, some noise may be introduced. That is referred to as external noise produced in the channel of communication. For example, when the signal is transmitted in this space, atmospheric noise, wind noise, factory noise, aeroplane noise, and etc. These are unwanted amplitude variations and mix with the actual amplitude variations of the message signal. This results into noise. This is known as atmospheric noise or cosmic noise. So external sources which may occur in the medium or channel of communication. Now, the noise is also produced by internal noise source. Actually, so we transmit, see this is wanted signal to be transmitted, that is our actual speech or voice or message signal. While transmitting into the space at channel, this is external noise introduced in this channel, transmitting from transmitting station between transmitting station and receiving station. Between these two, when the signal is transmitted, some noise is introduced, and therefore this noise, due to this noise, there may be some amplitude variations along with the original amplitude variations. This is referred to as external noise source. At the receiving station, the receiving station will receive the signals from all the different stations, and after receiving, you have to submit this received signal through number of electronic circuits to get back the original sound. These electronic circuit consists of transistors, certain other components, resistors, capacitors, etc. And when a current is made to pass through such components, the components may get heated up. Due to this heating up, some amplitude variations are produced in the electrical circuit at the receiving station itself. This may produce noise. So this may add some amplitude variations to the original wanted signal. So this is referred as internal noise. So the noise produced by the receiver equipments while it is doing its function is referred to as internal noise. Examples: thermal noise, short noise, and etc. It is produced within the receiver section itself. So by number of electrical and electronic circuits, due to heating effect, the noise is also produced at the receiving station itself. That is referred as internal noise. But however, for better and smooth transmission, the noise has to be reduced. It cannot be made zero. Noise has to be reduced. Therefore, we will define signal to noise ratio. This is the pure signal, along with there is some noise. Take the ratio of this original noise and ratio of the variation in amplitude due to noise. That is referred to as signal to noise ratio. Signal to noise ratio is defined as ratio of wanted signal to the noise present in the signal. If this is wanted signal, then ratio of this wanted signal to any noise present in that signal is divided by this noise. For better transmission, signal to noise ratio must be large. This is because when noise is in the denominator, when the noise is reduced, the denominator value is small, the ratio is very large. When noise is reduced, the transmission is better. Therefore, when noise is reduced from this expression, signal to noise ratio is large. So, higher the signal to noise ratio, better is the radio communication transmission. So, the radio communication transmission, better transmission is determined by signal to noise ratio. Thank you.